In today's revision, we are going to see first the image formation by a convex lens. The first position in which the object is placed at infinity. As we know, the light rays coming from a distant object are considered as the rays parallel to the principal axis of a convex lens. So when these parallel rays are incident on the convex lens, they are converged at its focus and we get a real and inverted highly diminished image of the object at the focus of the convex lens, and which is formed behind the lens. Now the second position, when the object is placed beyond 2f, that is at a distance which is more than the double of the focal length of the convex lens. One ray we are considering which is parallel to the principal axis, and the another ray which is passing through the optical center. This ray passing through the optical center will be undeviated and which will pass as it is without any deviation, and another ray which is parallel to the principal axis which will pass through the principal focus of the convex lens after refraction. By the intersection of these two rays, we will get an image which is real and inverted and which will be formed between f and 2f, and it will be smaller than the object. Now already we can see that it is formed behind the lens. Number 3, when the object is placed at a distance double of the focal length of the convex lens, that is object is placed at 2f, one ray which is parallel to the principal axis and the another ray that we are considering is passing through the optical center of the convex lens. This ray will be undeviated after refraction, and the ray which is parallel to the principal axis will pass through the principal focus of the convex lens. By intersection of these two rays, we will get an image exactly at 2f, that means on the other side of the convex lens at 2f, and of the same size, but it will be real and inverted. The next position of the object is when the object is placed between 2f and f, that means between the focus and the distance which is double of the focal length between them. Again, when we are considering two rays parallel to the principal axis, this ray will pass through the principal focus of the convex lens, and the ray which is passing through the optical center will be undeviated after refraction. By the intersection of these two rays, here we are getting a real inverted image behind the lens which is magnified, that is larger than the object, and it will be formed beyond 2f, that means at a distance which is more than the double of the focal length of the convex lens. Next position, when the object is at principal focus, here one ray which is parallel to the principal axis will pass through the principal focus on the other side of the convex lens, and the ray which is passing through the optical center will be undeviated after refraction. So we will get an image which is real and inverted and highly magnified, and it will be formed at infinity behind the lens. And the last position of the object, when the object is between optical center and the principal focus of the convex lens, here is the only one position of this object when it is placed between f and o of the convex lens. We will get a virtual and erect image, and that will be on the same side of the object which is there in front of the convex lens. The ray which is parallel to the principal axis, it appears that it is coming from the same side where the object is placed, and it passes through the principal focus, and also the ray which is passing through the optical center will when we forward it to the back side, it will intersect by this ray, and we get an virtual and erect image which is highly magnified, and it is at the same side of the convex lens where the object is placed. Now question is there, where should an object be placed so that a real and inverted image of the same size is obtained by a convex lens at the focus of the lens, at infinity, at twice the focal length, and between the optical center of the lens and its focus. So definitely the answer will be at twice the focal length. Now the next question is, a thin converging lens forms a real magnified image, and second virtual magnified image of an object placed in front of it. Write the position of the object in each case. Here the converging lens means the lens is a convex lens. Now real and magnified image, as we have seen a moment before, a real and magnified image will be formed when the object is placed between the focus and 2f, that means at a distance double of the focal length. We can see here 2f and f, the object will be placed between 2f and f. So this will be the diagram which we have to draw here. And virtual magnified image, just a moment before, as we have seen, when the object is placed between the focus and the optical center of the convex lens, so then we will get a virtual erect and magnified image. Now here, how will the following be affected on cutting this lens into two halves along the principal axis, focal length? Now the focal length will remain the same because the radius of curvature remains the same. Therefore intensity of image will decrease, because actually here we are considering only two rays, but actually there are so many rays which form the actual image. So when we cut the lens, the intensity of the image will decrease. Now the next question is, we have to analyze the given observation in which object distance and image distance have been given of a convex lens. Object distance, for object distance 90, the image distance is plus 18. For object distance minus 60, it is plus 20. For minus 30 centimeter, the image distance is plus 30 centimeter, and for minus 20 centimeter, the image distance is plus 60 centimeter. For minus 18 centimeter, it is plus 90 centimeter, and for minus 10 centimeter, it is plus 100 centimeter. What is the focal length of the convex lens? Give reason in support of your answer. When we see observation 3, the object distance and the image distance is same. That is, this is actually the position when the object is placed at 2f, that is the double of the focal length. Then only we are going to get the object image at the same distance behind the lens, that is at plus 30 centimeter. So if it is 30 centimeter, the focal length of the convex lens will be plus 15 centimeter. Now the second question, write the serial number of that observation which is not correct. How did you arrive at this conclusion? From serial number 3, here we have found that the focal length of the convex lens is 15 centimeter. Then from here we can see it is minus 10, that is the object length is less than its focal length. Then it is given that the image will be formed at plus 100 centimeter. So it is not correct, because at this time the image will be formed on the same side of the lens, that means where the object is placed at this side, and the image distance will also be negative. Now take an appropriate scale to draw ray diagram. So we can draw the ray diagram for the observation serial number 4. Serial number 4 means the object distance is minus 20 centimeter and the image distance is plus 60 centimeter. So here is the diagram for that.